Look up at the night sky. On a clear night you'll see a faint band of light stretching across the heavens. That's the Milky Way, our home galaxy. It's a vast collection of stars, gas, dust and planets, all held together by gravity. Our sun is just one of billions of stars within it. The Milky Way is constantly moving, changing and evolving. Its story is a journey through billions of years, from the dawn of the universe to its eventual fate. We live in a quiet corner of the Milky Way. Our solar system resides in one of the spiral arms, far from the galactic center. From our vantage point we can marvel at the Milky Way's splendor. We can study its structure and learn about its history. Understanding the Milky Way is about more than just satisfying our curiosity. It's about understanding our place in the cosmos. It's about piecing together the grand story of how galaxies form and evolve. Let's embark on a journey through time. Let's explore the evolution of the Milky Way, from its birth in the early universe to its predicted future. The Milky Way wasn't always the majestic spiral galaxy we see today. It emerged from a much humbler beginning, a chaotic cloud of gas and dark matter in the early universe. This cloud was vast, stretching for millions of light years. It was also incredibly dense, packed with the raw materials for stars and galaxies. Over time, gravity began to sculpt this cloud. Tiny fluctuations in density grew larger. Regions with slightly more mass exerted a stronger gravitational pull, drawing in more gas and dark matter. As these regions grew denser, they began to collapse under their own gravity. The collapse heated up the gas, causing it to glow. This glow marked the birth of the first stars in the Milky Way. These stars were massive and short-lived, quickly exhausting their nuclear fuel and exploding as supernovae. These explosions enriched the surrounding gas with heavier elements, paving the way for the formation of new generations of stars. The Milky Way continued to grow through a process called accretion. It pulled in smaller galaxies and streams of gas, adding to its mass and complexity. This process of growth and evolution has continued for billions of years, shaping the Milky Way into the galaxy we know today. But the story of the Milky Way's formation is not just about gravity and gas. It's also about the mysterious substance known as dark matter. The Milky Way is a barred spiral galaxy. This means it has a central bar-shaped structure made of stars. Spiraling out from the ends of this bar are several arms. These arms are where most of the Milky Way's star formation takes place. The spiral arms are not static structures, they are density waves that move through the galaxy. Imagine a traffic jam on a highway. The cars are still moving, but the jam itself moves more slowly. Similarly, stars and gas clouds move through the spiral arms, bunching up as they pass through. This bunching up triggers star formation. The central bulge of the Milky Way is a densely packed region of stars at the galaxy's core. It's thought to contain a supermassive black hole, a monstrous object with the mass of millions or even billions of suns. Surrounding the entire Milky Way is a vast halo of dark matter. This halo is invisible to telescopes, but its gravitational influence can be detected. The halo plays a crucial role in holding the galaxy together. It's the scaffolding upon which the Milky Way's visible matter is built. Stars are the building blocks of galaxies. They are born within giant clouds of gas and dust called nebulae. These nebulae are like stellar nurseries where gravity pulls together the raw materials for star formation. As the cloud collapses, it heats up and begins to spin. Eventually, the core of the cloud becomes so hot and dense that nuclear fusion ignites. Hydrogen atoms fuse to form helium, releasing an enormous amount of energy. A star is born. Stars come in a variety of sizes and colors. Massive stars burn bright and die young, exploding as supernovae. These explosions seed the interstellar medium with heavy elements, enriching the material from which future stars will form. Smaller stars, like our Sun, live much longer lives. They eventually exhaust their nuclear fuel and fade away as white dwarfs. Star formation and evolution play a vital role in shaping the Milky Way. The energy and heavy elements released by stars influence the interstellar medium, triggering the formation of new stars and shaping the galaxy's overall structure. But the Milky Way is not an isolated island in the universe. It interacts with its surroundings, sometimes with dramatic consequences. Section 5. The heart of the Milky Way. At the very center of the Milky Way lies a region of extreme conditions. This is the galactic center, a place where gravity reigns supreme. The stars here are packed together 1,000,000 times more densely than in our solar neighborhood. Lurking at the very heart of the galactic center is a supermassive black hole. This behemoth has a mass equivalent to millions of suns, all concentrated into a region smaller than our solar system. The black hole's gravity is so strong that nothing, not even light, can escape its grasp. While black holes are invisible by nature, their presence can be inferred by their effects on their surroundings. Astronomers observe stars orbiting the galactic center at incredible speeds. These speeds can only be explained by the gravitational pull of a supermassive black hole. The galactic center is a place of intense activity. The black hole devours gas and dust, releasing enormous amounts of energy in the process. This energy heats up the surrounding gas, causing it to emit radiation across the electromagnetic spectrum. While the galactic center may seem far removed from our quiet corner of the Milky Way, it plays a crucial role in the galaxy's evolution. Section 6. Galactic Encounters. The Milky Way is not alone in the universe. It's surrounded by dozens of smaller galaxies known as dwarf galaxies. These dwarf galaxies are constantly interacting with the Milky Way, both gravitationally and through the exchange of gas and stars. Sometimes these interactions can be dramatic. The Milky Way's gravity can tear apart dwarf galaxies, leaving behind streams of stars and gas that stretch across the sky. These streams are evidence of the Milky Way's ongoing cannibalism. In other cases, dwarf galaxies can merge with the Milky Way. These mergers can significantly impact the Milky Way's structure and evolution. They can trigger bursts of star formation, reshape the Milky Way's spiral arms, and even disrupt the orbits of stars in the galactic disk. Galactic interactions and mergers are a fundamental part of galaxy evolution. They drive the growth of galaxies, shape their morphologies, and influence their star formation histories. Section 7. The unseen hand of dark matter. We can't see it, touch it, or interact with it directly. Yet, dark matter plays a crucial role in the universe, especially in the formation and evolution of galaxies like our Milky Way. Astronomers first inferred the existence of dark matter by observing the rotation of galaxies. The stars in spiral galaxies rotate much faster than they should if they were only under the influence of the gravity of visible matter. This led to the hypothesis that there must be some invisible form of matter providing the extra gravity to hold these galaxies together. This invisible matter is what we call dark matter. Dark matter makes up the vast majority of the Milky Way's mass. It forms a halo that engulfs the visible galaxy. This halo acts like a giant cosmic web, providing the gravitational scaffolding that allows the Milky Way's stars and gas to clump together. Without dark matter, galaxies like the Milky Way would likely never have formed in the first place. They would have simply remained as diffuse clouds of gas, unable to overcome the outward pressure from their own rotation. Section 8. A fateful encounter with Andromeda. The Milky Way is on a collision course with its nearest large neighbor, the Andromeda galaxy. This may sound like a cataclysmic event, but galactic collisions are more like graceful mergers that unfold over billions of years. Currently, Andromeda is about 2.5 million light-years away from the Milky Way. However, the two galaxies are moving towards each other under the relentless pull of gravity. In about 4 billion years, they will make their first close pass, distorting each other's shapes with their immense gravitational tides. Over the next few billion years, the Milky Way and Andromeda will continue to dance around each other, their paths intertwined in a complex gravitational ballet. Eventually they will merge completely, forming a single, giant elliptical galaxy. This merger will have a profound impact on the Milky Way as we know it. The spiral arms will be disrupted, new stars will be born, and the supermassive black holes at the centers of both galaxies will eventually merge, releasing tremendous amounts of energy. Section 9. The ever-evolving Milky Way. The Milky Way's journey is a testament to the ever-changing nature of the cosmos. From its humble beginnings in the early universe to its future merger with Andromeda, the Milky Way has been shaped by a complex interplay of gravity, gas, stars, and dark matter. As we continue to study the Milky Way, we gain a deeper understanding of our place in the universe. We learn about the processes that govern the formation and evolution of galaxies. We uncover the secrets of starbirth and death, and we marvel at the vastness and complexity of the cosmos. The Milky Way is a dynamic and evolving entity. Its story is still being written, with each new discovery adding a new chapter to the ongoing saga of our home galaxy.